As I mentioned, I apologize, I didn't get the chance to post solutions, but I will. Between now and the final exam, please print out all blank tests and work on them as much as you can till you get everything correct, okay? As I mentioned, I will replace the lowest test grade with the final exam grade if that helps your grade. Okay?
You said the lowest test grade?
Yes. Yes, absolutely. Okay, so let's start trigonometry with chapter 5. And 5.1 deals with angles and radian measure. Okay. We have two types of angles. This angle, which is called a positive angle, alpha, is a positive angle. And this, let's call it beta, which is a negative angle. This is called the initial side. This side, this, initial, like here, initial, where the angle starts. And this is the terminal side. Of course, like this here. When we look at a circle, we know these points when it comes to angles. So how many degrees will this point have here? 0, right? 0 degrees. How many will this have up here?
90.
Okay. Of course here.
180.
Okay. And of course here,
270.
270 degrees. Excellent. Assume now that the radius is 1. So this measure is 1. Can anyone give us the circumference of a circle? Circumference.
2 pi r.
2 pi r. Since r in my example is 1, how much will this be?
2 pi.
2 pi, indeed. Since in my example, r is 1. This is a very important type of circle. It's called unit circle. I'm going to use it a lot. Why is it called unit circle? Because?
It has radius.
Because the radius is 1. Exactly. It's called the unit circle because the radius is 1. Very good. So now, in this case, could I say, and you'll tell me if you agree, that this, which is also, I should say here, 360 degrees, 360 degrees must be the same with 2 pi. Well, I know that this is degrees, but what is this? This is called radians. Radians. And if I divide both sides, I'll define a radian in a minute. If I divide both sides by 2 of this equation, by 2, what do I get? On the left-hand side, and on the right-hand side, pi. This is the conversion, the relationship between degrees and radians. We're going to work with this in a minute, but I want to define what a radian is for everyone to understand. So one more time, I made a special case here with a radius of 1. The circumference of this circle must be then 2 pi. So between this point and back at the same spot, I have 2 pi. Also, between this point and back to the same spot, I have 360 degrees. So therefore, 360 degrees must equal 2 pi. When we divide both sides by 2, we get this relationship. I will note here, very, very important relationship. 180 degrees equals pi. When I say pi, I really mean pi radians. If I don't say anything, it's radians. If I say 10 degrees, it's obviously degrees. If I say just 10, I mean radians. So when we say write pi, we don't really have to continue saying pi radians. So it's already understood. Okay, let's define radians. So I'm going back to a normal circle. This is a normal circle as well, but just any radius. So this is radius r. I measure this radius, the radius of the circle, and I put it here. What is this? How much is this? What is the length between this center and this point? Of course, right? So this is a radius, this is another radius, and this, we say the angle subtends a length of the radius. This measure, the measure of this angle, I'm going to call it alpha, is 1 radian. So what is a radian? It's the angle that subtends the measure of the radius. It's a central angle that subtends the measure of the radius. 1 radian. So let's find out how much is 1 radian. Because if you tell me graph 1 radian, I'll say, oh, wait a minute. How do I graph 1 radian? Or an angle of 1 radian? Or the central angle of 1 radian? Here's how I do it. If I know that 180 degrees equals pi radians, I'm going to write it, although we don't need to. How do I determine how much is 1 radian? What should I do to both sides of this equation to get just 1, not pi of those? Exactly. Divide both sides by pi. So 180 divided by pi will give us the measure of 1 radian in degrees. So let's do this together. So here it is, clear. So 180 degrees divided by pi. Here's pi right here, right? Pi is where the caret is. So 180 degrees divided by pi. So I know now, from now on, that 1 radian is approximately 57 degrees. And I know how to graph 57 degrees. So 1 radian, approximately 57 degrees. So now if you want me to graph 1 radian, I'll say, oh, so if this is 90, this is 30, this is 60, so obviously it's somewhere here. This alpha is 1 radian. If you want me to plot or graph an angle of 2 radians, oh, now I know how to do it. I'm going to say 2 times roughly 60, right? There's approximately 120 degrees. If you want to multiply, you'll get what? 114 degrees. So I know how to graph an angle beta of 2 radians. So roughly 120. How do I do that? This is 180. So this will be 30 and 30 and here, right? 90, 120. But this is not exactly 120. This is 150, 180. So this is 120 right here. 90 plus 30. So this is a little bit less. So roughly this is an angle beta of 2 radians. As long as I remember that 1 radian is roughly a little bit less than 60 degrees.
Weren't you using beta as the going the other way?
No, I pictured positive angles. I pictured positive angles.
So
You use the little fish one on top. I just know.
You mean alpha? So alpha here was 1 radian. Beta is 2 radian. So this is alpha, an angle that is 1 radian, and this is beta. This is the initial side, and this is the terminal side for an angle of 2 radians.
Are you just using beta?
We use Greek letters all the time in trig. Alpha, beta, gamma. Just to differentiate between 1 radian and 2 radian.
It's like using X.
Exactly.
Y,
We have to use,
or A,
yes,
B.
we have to use Greek letters. Yeah.
Why do you have that it's, I see we multiply 2 times 57.
Right. So
Why
this
do you
is
have-
this is roughly 60, right?
One
A little bit
radian,
less
right?
than 60.
Because that's 1 radian.
Right. Exactly.
And then what's the one? Does that say 120 or what's?
So 2 times 7 is 4, and I carry 1. 2 times 5 is 10, 11. So this is 114 degrees.
Okay, no, I said that, I was wondering what it's 160 on the side there.
Here?
Yeah.
No, 2 times 60, 120.
Oh.
Roughly 120.
But you wanted to get, so, but the exact is 140.
It would easier for me to graph 120 and then go backwards a
Oh.
little bit, because it's hard for me to graph 108 and 14 degrees.
Okay.
Very good. On one other thing that I wanted to mention before we look at problems, coterminal angles. What do you think coterminal means?
Equal angles?
No, coterminal means they have the same terminal, initial and terminal side. So for example, let's say I want to graph an angle of 30 degrees. So this is the initial side. I divide the first quadrant in 3, and this is 30 degrees. Alpha, 30 degrees. A coterminal angle with alpha will start at the same point and end at the same point. So an angle that starts here and ends here could be this. It starts on the x-axis, goes around the circle once, 360 degrees plus 30. So beta 390, alpha and beta are coterminal angles. They start at the same point and end at the same point. Can anyone give us another angle that starts at the same point and ends at the same point? Let's say gamma, but I want this time gamma to be a negative angle. It has to have the same terminal side and the same initial side. So it will start here and it will end here. Very good. Oops. Negative 330 degrees. That's what we mean by coterminal angles. So now I would like to look on page 529.
So it's
Yes.
one rotation starting from
The same spot, the x-axis.
and all the way to where the 30 degrees is.
Yes. Same initial side, same terminal side. Yep. Now I would like to look at some problems on page 529. I would like to convert from degrees to radians and back. And then find 2 coterminal angles. And that's all we need in this section.